Hey students, this is lesson 6.1, solving systems by graphing. You're going to learn how to solve system equations by graphing and to analyze special systems. All right, a little bit of review, stuff you need to know for this chapter. Solve each equation. If the equation is an identity, write identity. If it has no solution, write no solution. I'll do a couple of these so we can be reminded what each of these are. First one, if I solve that, I'm going to use the distributive property. 3 times 2 is 6. 3 times 2 is 6. So I get 6 minus 6x is equal to negative 6 times x. And when you take negative 6 times negative 1, you get plus 6. Now, if you think about these two, so I have 6 minus 6x. Let's say I add 6x to both sides here. Plus 6x. When I do that, I get 6 on this side, and I get 6 on this side. When that happens, when you get a true statement, that's an identity, and any number is a solution. All right, number 2, we get 3p plus 1 is equal to negative p plus 5. If I add p to both sides, I get 4p on this side, and I get just 0p plus 5 on that side. If I subtract 1 from both sides, I get 4p equals 4, and I get p equals 1. So that one has a solution. P is equal to 1. So the first one is an identity. All right, number 3. So I have 4x minus 1. I'm going to use the distributive property as I write this down. 3 times x plus 3 plus x. And I can simplify the right side. 3x plus x is the same as 4x plus 3. Now, if I were to subtract 4x from both sides, I would get negative 1 is equal to 3. But negative 1 is not equal to 3, so that's a false statement, which means there is no solution. I'll let you do the rest of them. Sorry about that, I had to get the phone. All right, solving inequalities. I'll do a couple of these with you. Again, the first one, 5x plus 3 is less than 18. I think we'll use the subtraction property of equality first. Subtract 3 from both sides. And we get that inequality. Then divide both sides by 5, and we get x is less than 3. On number 8, if we do, let's subtract 1 from both sides. Use the subtraction property of equality first, then we would get r divided, the opposite of r divided by 5, that's greater than or equal to negative 6 minus 1 is negative 7. Let's multiply both sides by 5, and then we get the opposite of r is greater than or equal to negative 35. And then let's divide both sides by negative 1 and get r. When you divide by a negative, you have to switch the sign. Is less than or equal to positive 35. I think I'll just let you do the rest of those. Just wanted to give you a problem or reminded us of the steps we need to take. Okay, to write a function, the height of a triangle is 1 centimeter less than twice the length of the base. Let x equal the length of the base. So write an expression for the height. The height is 1 centimeter less than twice the length of the base, which is x. So we're going to just call it 2x minus 1. And write a function rule for the area. The area of a triangle is 1/2 the base times the height. So we're going to do this as a function of x. And so we're going to take 1/2 the base, which is x, times the height, which is 2x minus 1. And then what is the area of such a triangle if the length of the base is 16? In other words, we are finding the area as a function of the base, which is 16. And so we're going to do 1/2 times 16 times quantity 2 times 16 minus 1. And that's 8 times 2 times 16 is 32 minus 1 is 31. And I think that's 248. All right. A little reminder on how to graph. We have 3 forms of equation here. Number 14 is in standard form. So we're going to attack that a certain way. Number 15 is in slope-intercept form. And the last one is in point-slope form. And each of those we could graph a little bit differently. When it's in standard form, you want to find the intercepts. In other words, if x is 0, what is y? And if y is 0, what is x? Well, if x is 0, that eliminates that part of the equation. So all we have to do is do -8 divided by 4, which is -2. And if y is 0, that eliminates this part of the equation. So we just have to do 2 times x equals -8. So x equals -4. Then we just graph those 2 points, 0, -2, right there, and -4, 0, which is right there, as long as our scale is 1. Then we just draw a line that goes through those 2 points. And that's the graph of that equation. All right, the second one is in slope-intercept form. So we know that y-intercept is 3. That's right here if our scale is 1. And our slope is -2/3, which means I'm dropping 2 for every 3 I go across. So if I go down 2 and over 3 and put a point, that would be a slope of -2/3. So there'd be another one there, another one there. And I want to draw a line through those points. And that's what that line would look like. All right, and the last one's in point-slope form. The slope, of course, is -2. That's right there. The point, now remember, in standard form, we have x minus x of 1 and y minus y sub 1 in point-slope form. So that means I'm subtracting 2, so my x coordinate is 2, and I'd be subtracting -5 to get +5, so my y coordinate is -5, so I'm going to have a point at 2, -5 over 2 down 5, that's right there. Now my slope is -2, which means every time I go over 1, I'm dropping 2. Every time I go 1 to the right, I'm dropping 2. So that would look like that. All those points. And then I can draw on that line. And there it is. Show that those lines are continuing. All right. Good review of essential skills. Okay, I'm just going to look through this and give you the answer. You can go ahead and pause here if you want. All right, what we're going to do is learn how to solve a system of equations by graphing. Now, a solution to a system is values that make both of the equations true at the same time. So we're looking for an x and a y value that make both this equation, y is equal to 2 times x minus 1, and the other equation, y is equal to 4 times x minus 7, true. Now, if we were to graph those two equations, the solution of the system would be a point that they have in common. And so, so let's go ahead and graph it and then just see what happens. If we graph y equals 2x minus 1, our y-intercept is -1, so let's put a point there. And then a slope of 2 means that for every 1 I go to the right, I'm increasing by 2. So that would be points along that line right there. And I can go ahead and draw that in. All right. And then the second equation, the y-intercept is -7, which is 1 more down here. And the slope is 4, so that means I'm going up 4 for every 1 I go over. So there should be a point right there, and right there. And notice they cross right there. And so right there is a point that is a solution to both of those equations. And it's the only point. And so I'm just going to write this down so you remember. We want, when we solve the system, we want an ordered pair. That makes both equations true. And we seem to have stumbled upon that when we graphed it as the point 3,5. Now, just to check that, that point should make both those equations true. In other words, if y is 5, so in the first equation, if I say 5 is equal, so I'm substituting these values in for x and y, is equal to 2 times 3 minus 1, we hope that's true. And 2 times 3 is 6 minus 1, which is 5. So that is true for that one. Now it also has to be true for the other equation. So when I substitute 5 for y and I substitute 3 for x, subtract 7, so we get 5 is equal to 12 minus 7. Well, that's also true. So they're true for both, so this is a solution to this system. So we can either say the solution is the ordered pair 3, 5, which means x is equal to 3 and y is equal to 5. Go ahead, you try the next one. Check back for the answers. All right, we're going to need a little more time, so we're going to call this part 1, and you can go ahead and check back for part 2.